In this video, we will solve systems of equations by graphing the system. In this set of problems, you will need graph paper. So first, let's talk about what a system of equations is. A system of equations is really just two or more equations that are occurring simultaneously. So no matter what, we just have in the same situation more than one equation. So what does a solution to this kind of thing look like? So let's remind ourselves what a solution to one equation looks like. A solution to one equation is any point that makes the equation true. So for example, this point, or this point, or this point. If we were to plug that point in, so this point here at 3, 1, I can plug in the x value of 3 and the y value of 1 and then solve both sides of that equation. So 2/3 times 3 is 2. 2 minus 1 is 1. So this point, when I plug it in, makes that equation true. If we were to plug in a point that was not on this line, it would make that false. For example, if I add another equation to this graph, I now have a system of equations. What if I tried that other point for this equation, y equals -1/2 x minus 1? What if I tried to plug in the point 3, 1? Will it be a solution for the blue line? Well, it shouldn't be because that point is off of the line. So when I solve that, plug in an x value of 3 and a y value of 1, I get a -3/2 minus 1, which is -5/2. And -5/2 is not equal to 1. So the point 3, 1 isn't a solution to the system. A solution to the system is any point that makes both the equations true at the same time. So logically, we can see that this point here is the same point for both equations. So what do you notice? So we noticed in that last one that it happened to be the point where those lines have a point on both equations. It's a point that makes both equations true. So which point satisfies both equations? Well, as we can see the blue line and the red line, we have the equation y equals 2/3 x minus 1 and y equals -1/2 x minus 1. This point here seems to be a point that's on both lines. So this point here is 0, -1. Let's try and see if that makes the equation true. Well, it makes the red equation true because it's on that line. It makes the blue equation true because it's on the blue line. So we notice that the solution is where those lines are intersecting. It's a point that both equations pass through. Now, what types of solutions can we have? Are there more possibilities than just one solution? There are actually 3 scenarios that we need to consider. So the types of solutions, well, we can have intersecting lines where the point where they cross is our one solution. So we have one solution where those cross. What about when the lines don't cross ever, when we have a set of parallel lines? Will we have a solution to the system then? Well, no, because the lines never intersect. So this is where we have no solution. There's never going to be a point that works for both equations. What if we have a system where the lines lie on top of one another? Where do those two lines cross? Well, notice they cross everywhere. If I have one line lying on top of one another, all of the points that are on those infinite lines will be a point that's a solution. So in this case, we have infinite solutions. So these are our 3 scenarios. For the rest of these problems, what I want you to do is I want you to graph the equations, and we're actually going to talk about these in class. So I'm going to go through all 8 examples so that you can copy down those equations and then graph those sets of lines. So the first set is here. Problem number 2. Problem number 3. Notice that problem number 3 here, those equations are not in slope-intercept form. For this set of notes, go ahead and convert all of the equations that are not in y equals mx plus b form to that slope-intercept format. Notice that on number 4, the first equation is not in slope-intercept form, but the second equation is in that y equals mx plus b format. So you only have to convert one of those equations here. On number 5, make sure you remember about Hoy and Vux and convert that equation. Number 6, number 7, and number 8.